Hello viewers, welcome back to class. I'm super excited to have you guys back to class again. I welcome you to Master Builders Online Academy. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos when they are uploaded. And guys, I stand to remind you one of our policy here, that you must not skip any part of this video, for this is your own advantage. Skipping any part of this video, you may skip the very vital aspect that will make you gain mastery over this aspect of this lesson. We also advise that anytime you are set to learn from our platform, avoid every unnecessary distraction. See how you can pay close attention so that you will be able to grab all that we have in stock for you. Then finally, if there be any part of this video you do not understand, maybe when you watch it for the very first time, please, you have a singular opportunity to replay the video over and over again until you understand that aspect. And that's the reason why these lessons are coming in video format. Don't forget to like, don't forget to subscribe, don't forget to share, and don't also forget to make your necessary comment at the comment section. And I stand to also tell you, if after replaying the video over and over again, you still have some questions to ask, or you need some areas to be more, or you need some areas where more clarification and in-depth explanation is needed, please, you can make us know that at the comment section below, where we attend to your comment and give you positive response anytime we get your comments. Now guys, let's get to the business of the day. We have been looking at second order differential equation just as we have it in the board. And we have looked at case 1 where f of s is equal to 0. We are equally looking at case 2 where f of s is not equal to 0 but any function of s. And any function of s, in this case, we have looked at a case where we have constant function. We have looked at a case also where we have linear function. But in this lesson, we are going to be looking at a case where we have quadratic function. Now on the board, we have part C, quadratic function of case 2. And for quadratic function, the f of x is always given as k², where I explained earlier that this k here can be 3, can have this as 3s², or 3s² plus 2x, or 3s² plus 2x plus 5. It can be this, it can be this, it can be this. All belong to the same family. All you look out for is the leading degree of x. The leading degree of x all through here is x raised to the power 3. So anything that comes behind is not your problem. Your attention should be on what is the leading degree of x. So in this case now, this, and this guy, they belong to the same category. So if at all it is only this one I solved, and in exam or in any textbook you will find exercise that have this function, it is the same method. Alright, it is the same method. But let's see how fast we can do to see if we can look at this, or this. But understand that we may look at just 2 questions under this aspect. But I just explained now that all problems under quadratic equation are solved the same way. So if it is either it comes in this way, or this way. Now, let's look at the very first question we have on the board, if that is understood. Question number 5. Don't forget that this is a continuation class, so this happens to be question number 5 under case 2. Now, we are asked to solve this square, y over dx² minus 3dy over dx plus y, 2y is equal to s², which is the quadratic. So, forget whether you have coefficients, forget whether you have other parameters. Your interest should be on the degree of x. What's the power of x2 is quadratic. Whether you have coefficients, you don't have, that shouldn't bother you. Your interest should be on the degree of x. So this is second degree, which is quadratic. And that's exactly what we have here as quadratic function. Now, when you are given for quadratic function, how do you solve the solution? Of course, we already know that for any second order differential equation where the right hand side is not equal to 0, we always have 2 results. First is the complementary function. Second is the particular integral, right? Now, for the particular integral, for the complementary function, that has already been taken care of. But for the particular integral, based on this case we are looking at, we obtain a particular integral using this model. Y is equal to x squared plus dx plus e. It starts from the degree, highest degree of x, down to constant. So all of these things, you can memorize them, you can also know them. If you have linear equation, it starts from x. If you have constant, you only have constant. But for any degree you have, it must descend down to constant. Are you there? If this is understood, that's all about it. So to find a particular integral, now we need to have this as our y. Then we will differentiate this function 2 consecutive times. Then we will now substitute into the given equation. We will have our answer and the result. Okay, now if that is understood, let's quickly solve this question number 1, which happens to be question number 5 in the series of questions that we are solving. So first is to call this equation 1. Like I said in an exam, you need to write this equation before you start solving. Now in this case now, what do? We define the future from the beginning. We therefore have that this final solution is equal to complementary function plus particular integral. We call this one equation 2. And now the next is finding the complementary function. Now we then have to find the complementary function. What do? We simply allow the f of x, the function of x at the right hand side of the given equation, to be 0. Then we say let the right hand side of this given equation to be 0. Then we are going to have this expression as d square y over the x squared minus 3dy over dx plus 2y is equal to 0. Then we tag this as equation 3. Having obtained equation 3 or make the right hand side of the given equation 0, the next thing you do is to deduce the auxiliary equation from equation 3. And the auxiliary equation is simply given as m squared. When you change the square y over the x squared to m, then minus the y over the x is m, then plus y is 1. So 2 multiplied by 1 is 2. This is equal to 0. And we tag this as what? Equation 3, equation 4. Now the next thing we are quickly going to do is to what? Solve this quadratic equation so that we can obtain 2 roots which will determine our complementary function. But before we can do that, we will now make choice of the method of quadratic equation we will use. But for me, we are going to make use of factorization method because looking at this question, I already know that this question is factorizable. You can check it out the way I have explained it in our previous lessons. Okay, now, if this is understood, so you multiply the highest degree of s with the constant. And when we multiply this guy with this guy, this will have given us plus 2m squared. And I've explained over time that for the product of 2 factors, now we need to look for 2 factors whose product will give us plus 2. And it is either we have 2 multiplied by 2 to have positive 2 here, or negative 2 multiplied by negative 1. This is a theory that for the product of 2 factors to be positive, it is either the 2 factors are positive, or the 2 factors are negative. This is the ground to which the product of 2 factors will give us positive outcome. Now, if this is understood now, we just have only 2 factors of 2. And among these 2 factors, only one is suitable for this question. Which is suitable now is the one whose sum will give us the middle function. And the middle term here is minus 3, which happens that this last term is what we give us. So we are going to have minus 2m and minus m to replace minus 3m, which is the middle term. It's as simple as this. So we are going to have this as m squared minus 2m minus m plus 2 equal to 0. So when I multiply this guy to this guy, we will have this guy. And when I add them up, we will have this middle guy. It's as simple as it. This is understood. Then let's push it. Now that we have successfully replaced the middle number with 2 other different factors, all we need to do is to group the first 2 terms and equally group the last 2 terms. Now that we have grouped them, all we need to do is to check between these first 2 terms what is common, and between the last 2 terms what is common. Now for the first 2 terms, what is common is just m. And when m squared is divided by m, we just have m. And when minus 2m is divided by m, we are left with minus 2. Then between m, we put down the middle sign, which is minus. Between m and 2, nothing is common. And when nothing is common, when we are factorizing the expression, 1 is always common. Then we put down 1 and repeat the first bracket that we have. This is equal to 0. Now that we are successfully factorizing, the next thing we are quickly going to do is to collect the multiplication factors, which are the factors that are outside the bracket, right? And now the first factor outside the bracket is m, the second is what? Minus 1. Then we will pick one of the equal brackets, and this is equal to 0. And by standard, mathematically accepted, we said that for the product of two factors of functions to be 0, it is either one of the factors is 0. It's either the first is 0 or the second is 0. But based on the fact that we are not sure of the factor that is 0, then we are going to assume both to be 0. Then we have is either the first is equal to 0, or this is the law of probability, m minus 2 is equal to 0. Now from here we are going to make m the zero formula. When I take 1 across the sign, it becomes positive 1, or when I take minus 2 to the other side, it becomes positive 2. Therefore, we have that m is equal to 1 or 2. With the result we have here now, we will be able to deduce the general solution to second order differential equation, who has a root that is equivalent to what we have here now. Now guys, identify these roots here. What are the roots that we have here? Real, number 1, then different, number 2. That is to say, we have m1 here and m2, and it is only in this mode here. We can therefore say that m1 is equal to 1 and m2 is equal to 2. So I therefore recall that the complementary function is equal to a exponent m1x plus b exponential m2x. It's as simple as this. So I can replace y with complementary function. I have that a exponent m1 is 1, so I'm going to have 1x, which is sitting as x, then plus b exponent 2x. This is the complementary function for this particular question. Now the next thing we are quickly going to look at is the particular integral. Guys, don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell so that anytime we upload mind-blowing content, while you are asleep or in your reading table, you will be notified, and you can quickly slide to your YouTube channel and watch to learn for yourselves. Now guys, let's continue from where we stopped. So the next thing we are quickly going to do here is to obtain the particular integral. You see that we are just applying steps, principles, and that's the reason why I said earlier, when you understand principles, you suddenly become a principal, and when you understand boundary conditions, you will not overstep your boundaries. Now, so we have to find the particular integral. Are you there? We have that particular integral here is equal to y, and y is equal to the constant start from x squared quadratic plus dx plus e. Start from the highest power of x down to constant. You don't need to memorize this. Okay, if this is understood, now that we have gotten y, all we need to do is to differentiate y with respect to x. Now, when we differentiate y, when we differentiate c x, don't forget that c is a constant. So when I differentiate x squared, the power of x will come down. This will be giving us 2x. Then we reduce the power by 1. We have 1. Plus, when we differentiate dx, s will disappear. We have d. And when we differentiate it being a constant, is 0. Then we ignore that. Then we differentiate again d squared y over the s squared is equal to. Now, when we differentiate the first derivative to obtain the second derivative, when we differentiate c, 2cx, s disappears, we have 2c, and when we differentiate db, that is a constant, is 0. That's all. Then the next thing we are quickly going to do here, guys, is to substitute these values we just have here now into the given equation, which is equation 1. Are you there? Once you obtain y, you obtain the y over the s and this square y over the s square. Just impute their values into the given equation, which happens to be the equation we have as equation 1. That's all. So we'll come here. The first value here is this square y over the s square, and it happens to be 2c. Put it there. That's all. Then minus 3d squared dy over the s, and the y over the s is 2c x plus d. Are you there? Then plus 2y. And what is y? Don't forget our y is equal to c s squared plus dx plus c plus e Then all equal to what? At the right hand side of the equation, we have S squared. It's as simple as this. Very, very simple. So simple. Now, guys, what's the next thing we're quickly going to do? The next thing we are quickly going to do here is to what? Remove the brackets. And to remove the brackets, we just expand. When we expand it, this will have given us 2c. Minus 3 multiplied by this, we have minus 6c x. Minus 3 multiplied by d, we have minus 3d. 2 multiplied by this, everything inside is going to have 2cs squared plus 2dx plus 2e is equal to x squared. Now we have x squared here, we have x, and we have constant term, which are terms without x. So what we need to do is to what? Either rearrange it first or just compare both sides. Let's first of all arrange this equation at the left hand side in the order of their degree. So the only power of x squared that we have here now is 2cs squared. So let's arrange. We have 2cs squared. Then for x I have this guy and this guy. So I can pick 2d first since it's positive, plus 2d, then minus 6c, all multiplied by x. Then for the constant term, I have c, I have 3d, then I have 2e. So I can start with 2c plus 2c, then minus 3d, then plus 2e, all equal to x squared. Are we there? Now, the next thing we are quickly going to do, now that we have arranged it, all we need to do now is to compare both sides. Because like I explained earlier, we need to obtain the true value of c, d, and e. And for us to be able to obtain numbers of unknown from one equation, what you use is comparison method. Are you there? So let's quickly use comparison method here. We have x squared here in this equation. We have x, and we have constant term. So now, for s squared, at the left hand side, I only have 2c as s squared. So I'll pick only the coefficient, which is 2c. Then at the right hand side, I have 1 s squared. Don't forget that the coefficient of s squared there is 1. So I pick only the coefficient, which is 1. This I call equation A. Then from this other guy, for x, the function of x that I have at the left hand side is everything I have in this bracket. So I have 2d minus 6c. At the right hand side, I do not have any s function. That is 0. So since I do not have constant term s function at the right hand side of the equation, then I put 0. Similarly, for constant term, we have 2c minus 3d plus 2e is equal to, I do not have constant at the right hand side, then it's also equal to 0. This is c. Okay. Now from equation A, let's start from equation A. From equation A, we will make c the sort of formula, and we are going to have this as c is equal to 1 divided by 2. That's all. To make c sort of formula, all we simply do is to divide both sides by 2. That's all we have. Then secondly, we have this, which is what? From equation B. Alright? We are going to make this sort of formula. Then we have 2d. As we take minus 6c to the right hand side, we automatically have this as what? Positive 6c. Then d would have given us 6c over 2, which was giving us 3c. And guys, what is c? C is 1 over 2. Then I automatically have this as 3 over 2. Because 3 multiplied by 1 over 2 will give us 3 over 2. We have successfully obtained the value for d. Now we obtain c and d. Then we are left with what? E. And we will find the value of e from equation C. Now from equation C, let's make e sort of formula. We have 2e is equal to what? 3d. As minus 3d crosses, it becomes positive 3d. And as minus 2c crosses, it becomes negative 3c. This is. And now we have this as equivalent. What's the value of d? Value of B is what? 3 over 2. So we have 3 into 3 over 2 minus 2 multiplied by the value of C is 1. Then we have 1 over 2 is 1 over 2. Then we have that. Now we need to simplify. We therefore have 2e is equal to, when we multiply the numerator, we have 9 over 2. And when we also multiply the numerator, we have 2 over 2. Are we there? Now, anytime you have equal denominator, you can subtract or add the numerator. The denominator here is 2, the denominator here is equally 2. So let's add up or find the difference of the numerator, and this would have given us 9 minus 2 would have given us 7 over 2. Now to find E, we therefore have E is equal to 7 over 2 divided by 2. Is that correct? So we therefore multiply both sides by what? 1 over 2. And automatically this would have given us 7 over 4. Okay? Is that taken? Then we have 7 over 4. This is the answer to both what? C, D, and E. All we need to do now is to record the general solution for the particular integral. What's the particular integral? We said that particular integral is equal to C S squared plus dx plus E. So we have, what is C? C is 1 over 2, which is written as x squared over 2. Then plus D is equal to what? 3 over 2. Then this will give us 3x over 2. Then E is 7 over 4. This is 7 over 4. This is the what? Answer to the particular integral. Guys, now that we have gotten the complementary function and particular integral, then we need to just substitute into equation 2 to get the final answer. Then we recall that the general solution y is equal to complementary function plus particular integral. Then y is equal to a. What's the complementary function? A exponent x plus b exponent 2x plus what's the particular integral? S squared over 2 plus 3x over 2 plus 7 over 4. This is the answer to this second order differential equation. Now guys, we have question number 6 on the board. Okay? Question number 6 on the board. We are asked to solve this square y over the x squared minus 4dy over the x plus 3y is equal to 5s squared plus x. S squared. That shows that we are dealing with quadratic. This first term is what controls. Forget about every other thing that comes behind. Are you there? So we show that this second order differential equation we are given now is not equated to 0. Therefore, we have a combination of particular integral and complementary function here to get the general solution. So we state our solution and then state the future from the beginning, which is complementary function plus the particular integral. This we call equation 2 if we label this as equation 1. Okay? Now, the next thing we are quickly going to do is to see how we can obtain the complementary function. Guys, this is very simple. How do we obtain complementary function? You simply obtain the complementary function by taking the f of x at the right hand side of the equation as 0, or equating the right hand side of the equation to be 0. Are we there? Then we simply say to find complementary function, let the right hand side of the equation be equal to 0. So if the right hand side of the equation is equal to 0, then we can have this to be what? D square y over the x squared minus 4dy over dx plus 3y is equal to 0. We call this equation 3. Are we there? Now that we have obtained equation 3, or we have successfully equated the right hand side of this equation to be 0, then all we simply need to do is to obtain the auxiliary equation, because we only obtain auxiliary equation when the right hand side of any second order differential equation is 0. Now we already have it in that condition. Then we can deduce the auxiliary equation, where this becomes m squared, then minus 4m, then plus 3 multiplied by 1 is 3 equal to 0, and we call this equation 4. Don't forget that equation form is the auxiliary equation. But when you are writing this in exam, ensure that you state it before you put down this equation. Or after putting down this equation, then you can state that equation form is an auxiliary equation. Now, from equation 4 now, we can now see that we have a quadratic equation. And for every quadratic equation, there are about 4 methods of solving them, so you can make use of a method of your choice. The best method you know how to use this, alright? But in this case now, we are going to use factorization method because looking at this question, I've already seen that factorization method can work this out, okay? So we have this multiplied by this, and this will have given us plus 3m squared. So we are going to look for two factors of 3, positive 3, whose product will give us 3, and sum would have given us minus 4. Then, and I explained earlier that for the product of two factors to give you a positive result, this either both are positive or both are negative. So this guy multiplied by this guy is plus 3. This guy multiplied by this guy is also plus 3. But among these two factors, one will be suitable for this question. The one that will be suitable for this question is the one whose sum will give us what? Negative 4, which happens to be the coefficient of the middle term. It's as simple as this. So we are going to go with this minus 3 minus 1 will have given us minus 4. So we will replace 4m, which is the middle term, by having this m squared minus 3m minus m plus 3 equal to 0. It's as simple as this. So at this point, guys, we will group the first two terms and equally group the last two terms. Now, between the first two terms, only m is common. Now, m squared divided by m, we have m, and 3m divided by m, we have 3. Then minus. This is m, this is 3, nothing is common. And when nothing is common, 1 is common. There you have 1 minus 3 equal to 0. So, very quickly, we will take the multiplication factors, which are the numbers outside the bracket. So, I have m, then I have minus 1 outside the bracket. To form one bracket, then pick one of the equal bracket, which is m minus 3, all equal to 0. And we understand mathematically that for the product of two factors to be 0, one of them must be 0. It is either the first is 0 or the second is 0. Then we bring in probability. Here we have either m minus 1 is equal to 0 or m minus 3 is equal to 0. Now when we take negative 1 from the left to the right, it becomes positive 1. And equally, when we take negative 3 from the left to the right, we have positive 3. Finally, we have that m is equal to 1 or 3. From the result we have here now, we see that these two values, these two roots are real and are different. That means we can call this m1 and we call this m2. Therefore, here m1 is equal to 1 and m2 is equal to 3. So you quickly recall the solution to second order differential equation where you have what real and different roots. There we have y is equal to a e m1 of x plus b e m2 of x. Now we can replace this with complementary function and have a e exponential 1x, which is exponential x, plus b exponential 3x. We have successfully obtained the complementary function. Now we have gotten the first class. Then we look at the second. Now to find particular integral, the methods are the same with constant, linear, or even quadratic. All you just need to know is to know the particular formula you need to make use of. Now we state here that to find the particular integral, we know that particular integral is equal to y, and y is equal to cx squared plus dx plus e. Being that this is quadratic, just look at the right hand side of the given equation and see the leading power of x, and this is quadratic. Okay, that's why we have it. If this is 3, then you are going to have this as 3, 2, ex plus f, just like that. Okay, now that we already have y, we can differentiate with respect to x to have this as what 2cx. You understand that the 2 will come down, reduce the power by 1, you have this. Then when you differentiate dx, you have the, when you differentiate e, which is constant, that's 0. Then we differentiate again. D square y over the x squared. when we differentiate this first derivative to obtain the second derivative, if we differentiate 2cx, we will be left with 2c. S will disappear. Then we have 2c. And when we differentiate d being a constant is 0. All we need to do now that we know we have obtained y, dy over dx, and d square y over dx square, we just quickly come and substitute these three values into the given equation, which we have termed as equation 1. That's all. Usually the processes are the same. When you know principles, you become principals. You will never be stranded. You are always stranded because you do not know the way out. And the easiest way to know the way out is to know the principles. Because when you understand boundary conditions, you will not overstep your boundaries. Alright, don't forget, subscribe to this YouTube channel if you have not done so. And ensure that you turn on the post notification bell for more exciting videos when being uploaded. And get this clear, there is no way you can turn on the post notification bell without first subscribing to our channel. Of course, you have got a lot of values here. Please subscribe, share, like, and make your necessary comments. Okay, so one, and replace everything here with 2c. Then minus 4 multiplied by dy over the x is 2cx plus d. Then plus 3 multiplied by y. We have y to be what? Cx squared plus dx plus e, all equal to what? 5x squared plus x. Is that clear? That's it. 5x squared plus x. Now that we have gotten this, the next thing we quickly do is to multiply out this bracket. And when we have this done, this would have given us 2c minus 8cx minus 4d. We just open the bracket. Then 3cx squared. Are you there? Then plus 3dx plus 3e is equal to 5x squared plus x. Are we here? This is it. Now, the next thing we will do here is to what? Arrange this equation in the order of degree of x. So the highest degree of x here is s squared. So we start from s squared, followed by s, then followed by the constant 10. Just the same way the right hand side is arranged. Are you there? That's it. Then here we will have this as 3cx squared. Then all the x, we will collate them together, plus 3d minus 8c, all multiplied by x. Then for the constants, I have 2c minus 4d plus 3e is equal to 5x squared plus x. At this point where we are, all we just simply need to do is to obtain the value of c, d, and e. And we have all of this in one equation. And you understand that for us to be able to obtain numbers of unknown from one equation, we make use of what? Comparison method. Alright? Unlike simultaneous equation, where the number of unknown must be equal to the number of equations before you can have them solved. That's exactly what we have. Now let's do it. So now what are the degrees of x that we have? We have x squared. Using comparison method, you can state it. Then we have x. Then we have constant 10, which are the terms without x. So now at the left hand side of the given equation here, we find out that the only place where we have s squared is just 3cx squared. So we will ignore the s squared and pick only the coefficient because we have already stated s squared there. So pick only the coefficient, which is 3c. Then we move to the right hand side. At the right hand side, we also have 5s squared. We will ignore the s squared and take only the coefficient. And the coefficient of s squared there is 5. And that's what we call it comparison method. So in comparison method, all you simply do is to pick only their coefficient. So we can call this one equation A. Then from the next is what? We are going to pick the coefficient of x. So we come to the left hand side. The coefficient of x is 3d minus 8c. 3d minus 8c is equal to, at the right hand side, we have 1x. 1x. So the coefficient of x there is 1. Then we will equate this to 1. This becomes equation B. Then finally for the constant, we have 2c minus 4d plus 3e is equal to, now at the right hand side you discover that there is no constant. Since we do not have constant, then we are going to put 0 there. So we have 0, and this is equation C. It's as simple as this. So we will now start solving from equation A. Now from equation A, we have that C, we will divide both sides by 3, is equal to 5 over 3. Then from equation B, we will have that 3D is equal to 1 plus 8C. Hope you can see that with it. 1 plus 8C. And this will be equivalent to what? 1 plus 8 multiplied by 5 over 3. And this is equivalent to what? 1 plus 40 over 3. Now this is 1. Okay? It's as simple as this. All you need to do, the LCM of 3 and 1 is 3. So just multiply 1 by 3, which would have given us what? 3. Add 3 to 4, you have 43 over 3. So here we are going to have this as 43 over 3. 3 multiplied by 1 is 3. 3 plus 40 is 43. Then we now have that D is equal to 43 over 3 multiplied by, now we are going to divide both sides by 3 so that we can have the, then multiply by 1 over 3. And finally the answer to this would have given us 43 over 9. We have equally obtained the answer to D. Very simple. You can simplify this and take a lot of space. No wahala. We are trying to minimize this so that we can have everything solved within the space that we have here. Okay? Now this is it. Then to find E, because we have find C and D, so we are left with E. Because we have 3 unknowns, we will quickly make use of equation C. So from C, we have that E, 3E. Okay, let's put it here. We have that 3E is equal to what? 4D minus 2C. So let's quickly substitute for D and C. So by extension, we have 4 multiplied by D is 43 over 9. Are we there? Yeah, we have 43 over 9. Then minus 2 multiplied by C, we have 5 over 3. And now this will have given us 3E is equal to 43 multiplied by 4. 4 multiplied by 3 is 2. Carry 1. 4 multiplied by 4 is 16 plus the 1 you carry have 172. All over 9 multiplied by 2 multiplied by that guy is 10 over 3. As simple as this. Now what do you do? LCM of 9 and 3 is 9. So we equate this as 9 all over 9 divided by 9 we have 1. Now 1 multiplied by 172 we have 172 minus 9 divided by 3 is what? 9 is 3 and 3 multiplied by 10 we have 30. Therefore we have E is equal to, when we remove 30 from 172 we will have 142 over 9. We have 142 over 9 multiplied by, don't forget that we are going to divide both sides by 3. So we just say 1 over 3. And this will have given us 142 all over 1 all over 27. 9 multiplied by 3 is 27. So we have E as this. Then finally, all we just need to do here to get our final result is to recall that particular integral is equal to Cx² plus Dx plus E. It's as simple as this. Okay, so we have our particular integral as, what is C? C is 5x squared over 3. Then plus D is 43 over 9. 3x over 9. Plus E is 142 over 27. Now this is the particular integral. Then when we get the final answer, you now come back to equation 2 which is the future that we define before we begin this journey, right? Now we have that the general solution y is equal to a complementary function plus particular integral. Then we have final answer to the what? The complementary function we have is e exponent x plus b a exponent 3x plus the complementary function is 5x squared over 3 plus 43x over 9 plus 142 over 27. This is the answer to this particular question. This is it. So guys, you find out that this is very simple. Though the steps are very lengthy, very long, but it is simple if you understand the principles. Now, don't forget to subscribe to this YouTube channel if you have not done so. Ensure that you turn on the post notification bell. More exciting videos will be uploaded. Also, don't forget to like this video, share this video, and make your necessary comment at the comment section. Guys, you can slide down to the description below where you will find the link to the next video. We love you. Thank you for watching. See you guys in the next class.